Good day to you. If you have a moment, I'd like to share with you some things I have found out about atoms. Wonderful. I am Albert, pleased to make your acquaintance. This will only take a few minutes. I know you know all about the atom, protons, neutrons, and electrons, but they are the smallest piece of matter that still keeps the properties of the element. Most likely, you even know what they look like. But do you know the history of how we figured all this out? The first person to have the idea of an atom was the ancient Greek philosopher, Democritus. He said that elements were made of tiny, solid particles that could not be divided into anything smaller. He called these particles atomos, which means uncuttable. So, the word atom just means uncuttable. A scientist, named John Dalton, modernized the idea, saying that an atom was a solid sphere. Even then, we kept the basic concept of a solid, uncuttable particle that makes up all of the elements, until the early 1900s. In case you don't remember, a sphere is a round, three-dimensional object. Kind of like a soccer ball, but in this case it is solid, like a bowling ball or a marble. In 1904, J.J. Thomson, a scientist in England, inferred from some experiments that he was doing that an atom was made of at least two smaller parts. Small negatively charged parts, he called electrons, that were evenly spread around inside the positively charged sphere. A few years later, in 1911, Ernest Rutherford, another English scientist, modified the idea of the atom even more. He said that there were two regions of an atom: a positively charged nucleus, containing almost all the mass, and the area around the nucleus, where the electrons orbited. Rutherford's idea was pretty close to what we have today, but there were still some discoveries and improvements to the atomic model to be made. Niels Bohr, from Denmark, formed a hypothesis that electrons travel in fixed orbits around Rutherford's positively charged nucleus. Even further, James Chadwick, one of Bohr's students, concluded that there were both positive protons and neutral neutrons in the nucleus. Which brings us to our current electron cloud model. The electron cloud model takes parts from the previous ideas but also puts in new understandings of the behavior of the atom. There is still a positively charged center of the atom, containing the protons and neutrons, where almost all the mass is located. And electrons orbiting the nucleus. But instead of them being in fixed orbits, like in the Bohr model, or just randomly spinning around, like in the Rutherford model, electrons tend to be in insertion areas more frequently at any given time. There are still specific orbit levels, but electrons switch around and never stay in the same level very long. We still use the Bohr model to show electron levels and atomic structure, because it is easy to understand. But the electron cloud model is still the most current and most accurate. In reality, the electron cloud is a blur, containing all the electrons of an atom in it, somewhere. It is important to remember that most of an atom is empty space. I know it is hard to imagine that the ground I am standing on is made of mostly nothing, but it is true. It is kind of like trying to stick your hand through a fan. Of course you can't, the blades are moving too fast. Electrons are moving at near the speed of light, so they give the appearance of being solid. I hope that you will take some time and reflect on the different people who over time, helped us to better understand atoms, and ultimately, better understand ourselves. And always remember that science matters. And that I'm not your daddy. I'm your grandpa. Excuse me. I think I will be going now. If anyone asks, you know the drill. See you.